Welcome to Math 63, Unit 2, Lecture 1, Part 3, Simplifying Expressions. Here's some examples.
Okay, so here we have what's called an algebraic expression. Okay, it's not an equation because there's no equal sign, it's just an expression. This is some bit of math, basically. What I want to do is simplify this, which in this context just means get rid of those brackets and say what would this be without brackets. Okay, so what I can do here is use the distributive law. The distributive law is a rule that talks about how multiplication and addition interact, and the distributive law in general is if I have A times B plus C, then that's going to equal A times B plus A times C. So the thought is like this. So that's the distributive law. And doing this process is called distributing. Okay? I should point out that if you go in the other direction, it's called common factoring, and you might remember that from your high school days perhaps. Okay, so distributive law can be read in both directions. We're going to focus on distributing here. So we're going to multiply both parts of this by 5. So 5 times 3x, well, we're just going to multiply the 5 and the 3, and the x sticks around. So we have 15x, and 5 times 2 is 10. So this simplified is just simply that. Okay, now let's look at this example. All right, to simplify this, once again, we've got something to distribute, so we'll distribute that first. And then we're going to do a thing called collecting like terms. So let's start with the distribution. So we're going to multiply 10 by 3x, so that's going to be 30x. And then we're going 10 times negative 6. So when I see a subtraction, I'm just going to think of that as a negative instead, just because it makes things easier. So I'm going to think of this as 3x plus negative 6, okay? It's the same in the end as just saying, okay, 10 times 6 is 60. And so this becomes 60. Now we have 72 minus 15x. Okay, cool. So from here, we can now rearrange, and this is why I like to think of subtraction as adding but with a negative, because I can rearrange this so long as I keep the negatives on my stuck with the numbers or the terms that they're with. Okay, so I could rearrange this to be 30x minus 15x, because this is just plus negative 15x. So addition is commutative, meaning I can move things around, but subtraction isn't. But since I'm treating this like it's addition with negatives, it all will work out. So I can do that, and then I could write plus 72 minus 60. Okay, so now this is just a simple matter of doing the subtractions. 30 minus 15, or 30x minus 15x, is 15x. And now 72 minus 60 is positive 12. All right, so this long expression boils down to 15x plus 12. All right, let's do one more example. Okay, so in this example, all right, we've got a fraction as well as a subtraction with brackets. So the way that you can think of this fraction, okay, this fraction bar acts like a bracket. So this is really saying 9x minus 1 divided by 3. Or, because we know how fractions work now, let's rewrite this saying rather than divide by 3, let's just write it as multiplied by 1/3. Okay, and then minus 7x minus 5. Okay, so now I could rewrite this as I could distribute. So I can distribute from the other side too. Distribution doesn't have to be just from the left, it could be from the right. And the reason for that is multiplication is commutative, so which side we do it from doesn't matter. So we now have 9 times 1/3, which is 3. So we have 3x. And now we have minus 1 times 1/3, which is 1/3. Now over here, I'm going to treat this negative like it's a -1. All right, and I'm going to multiply it through. Right, because this is really adding the negative of this. So adding -1 of this, let's say. So what this turns out into is negative 7x, and then minus 5. Minus 5 is plus 5. So what I end up with is 3 minus 7x, right? If I did this the old way, I could, well, not the old way, if I did this the same way I did back here, I could rearrange them, okay? But hopefully you understand that now, so we can do this in our head. 3 minus 7x is negative 4x, okay? And we have 5 minus 1/3. So let's just write that down once to think about it. So we have negative 4x, 5 minus 1/3. That's going to be, well, it'll end up being, well, 5 is 4 3/3 is a way to think of it, and subtracting the 1/3 from those 3/3 gives me 2. So this is going to be 4 2/3 is a way to handle that. All right, so there we go. So we've simplified a few expressions now. This is good.